Hey guys, so today I'm going to create a quick video to show you two different aspects of the mole. The first one is the conversions involving Avogadro's number, and the second one is showing you how to calculate molar masses, and hopefully this will give you a couple of examples to work with here. So the first example we're going to look at is right here. How many hydrogen atoms are in 0.350 moles of glucose, which is C6H12O6? So the first thing we're going to do is we're going to go ahead and we're going to set up our known information, and we're going to set up our conversion factors. Okay, so when we read this question, what we know without any thinking at all, the known information is that there are 0.350 moles of glucose C6H12O6. What we also know is we're trying to convert from moles of glucose C6H12O6 to what? Hydrogen atoms. So the question is, what are the conversion factors that are going to allow us to go ahead and set this up? Okay, the conversion factors that we need are, well, we need to go from moles to atoms. So what we know is that for every 1 mole of glucose, C6H12O6, that's going to equal 6.022 times 10 to the 23rd molecules of glucose, C6H12O6. Okay, so we're dealing with just this one molecule right now. Why? Because we started with moles of this molecule, and so we have to be able to convert to actual number of molecules. Well, the interesting thing is, once we know the number of molecules, we also know that for every 1 molecule of C6H12O6, that equals 12 hydrogen atoms. So you can kind of see the setup already. I'm going to go ahead and change colors here so that we can all be on the same page of what's going on here. What we can see now is if we start with our 0.350 moles of C6H12O6 and put that over 1, we can now convert using Avogadro's number, which shows us that for every 1 mole of C6H12O6, this is a 6 right here, we're going to have 6.022 times 10 to the 23rd molecules of C6H12O6. Okay? If we stop right here, what's going to happen is our moles of glucose will cancel. We'll be left with molecules of glucose. Now what we know is for every 1 molecule of C6H12O6, you're going to have 12 atoms of hydrogen. Okay? Now your molecules of glucose will cancel, like so, and now we can perform the calculation. We can see that over here, 0.350 times 6.022 times 10 to the 23rd, which is Avogadro's number, times 12 is going to equal, 2.53 times 10 to the 23rd, I'm sorry, times 10 to the 23rd, not 23rd, 10 to the 24th, one more time, 2.53 times 10 to the 24th atoms of hydrogen. Okay, so pretty straightforward. All right, let's take a look at another example. We want to know how many oxygen atoms are in 0.25 and 0.25 moles of calcium nitrate. Well, the first thing we need is the formula for calcium nitrate. So you should remember CaNO3 2. Okay, so how many oxygen atoms are in that situation? So what we need to know, or what we do know by reading the question, is that there's 0.25 moles of CaNO3 2, and that we're trying to go from moles of CaNO3 2 to atoms of oxygen. So the same general setup. Our conversion factors are going to be, well, to go from moles to molecules, we know that 1 mole of calcium nitrate, CaNO3 is going to equal, not molecules, but 6.022 times 10 to the 23rd formula units of CaNO3, because remember, with our formula units are because it's an ionic compound. And then we know by looking at this formula that every 1 formula unit of calcium nitrate, CaNO3 is going to include some number of oxygen atoms. In this case, it's going to be 6, 3 for each of the nitrates here, and there's 2 nitrates. So the 6 atoms of oxygen. Okay. Now we can go ahead and set this up, and we can see that with 0.25 moles of CaNO3 over 1, for every 1 mole of CaNO3, you're going to have 6.022 times 10 to the 23rd formula units of CaNO3, and then we know that for every 1 formula unit of CaNO3, you're going to have 6 atoms of, not sulfur, of 6 atoms of oxygen. Okay, so now we can go ahead and perform that calculation. We can see, clear this out, 0.25 times 6.022 times 10 to the 23rd times 6 equals, come back over here, it's going to equal 9.03 times 10 to the 23rd atoms of oxygen. Okay, that tells us it's a little bit more than a mole of oxygen, because 1 mole of oxygen atoms would be 6.022 times 10 to the 23rd. Okay, so keep that in mind. The next thing we're going to take a look at is what's the mass of 1 mole of glucose. Okay, so calculating molar masses are a little bit different. Still a very, very straightforward process. I'd like you to use the process that I'm going to show you here, and there's a method to my madness, and the reason is for something we're going to be doing later. When we talk about 1 mole of glucose, we're talking about 1 mole of glucose molecules. Okay, so what I want you to keep in mind is that the formula for glucose is C6H12O6. Okay, so in 1 mole of glucose, okay, in 1 mole of glucose, there's going to be 6 moles of carbon atoms. Okay, we know they're going to be 12 moles of hydrogen atoms, and they're going to be 6 moles of oxygen atoms. And the reason for that is because for 1 mole of the molecule, there's got to be 6 times 1 mole of the equivalent carbons, 12 times the 1 mole equivalent for hydrogens, and so on and so forth. Well, if you have your periodic table out, what you know is that 6 moles of carbon can be easily converted into grams of carbon, because we know that 1 mole of carbon atoms is equal to 12.01 grams of carbon. Okay, so 6 times 12.01 is equal to 72.06 grams of carbon. Similarly, 12 moles of hydrogen over 1 times, for every 1 mole of hydrogen atoms, we know there's going to be equivalent of 1.01 grams of hydrogen, which is going to equal 12.12 grams of hydrogen. And then finally, 6 moles of oxygen over 1, sorry about the little squiggly there, is equal to, for every 1 mole of oxygen atoms, you're going to have 16.00 grams of oxygen. Just for consistency's sake, we'll always round our molar masses to 2 places. So 16 times 6 is equal to what? Equal to 96.00 grams of oxygen. So to know the total molar mass, what we want to do is we want to add the mass of each component. So we'll come back over here. We're going to say, okay, we've got 72.06 plus 12.12 plus 96.00, and that equals 180.18. So we'd say that over here the total molar mass is going to be equal to 180.18 grams of C6H12O6 for every 1 mole of that same substance. Okay. Finally, we've got the calcium nitrate. Same general process. Okay, same general process here. I'll go purple this time. Okay, and what we know is the formula was CaNO3 2. So for every 1 mole of calcium nitrate, there's going to be 1 mole of calcium. 1 mole of calcium. For every 1 mole of calcium nitrate, there's going to be 2 moles of nitrate, which means there's going to be 2 moles of nitrogen and 6 moles of oxygen. 1 mole of calcium over 1. We've got 1 mole of calcium. Calcium is one of the few elements that I don't know right off the top of my head by looking at it, so I need to look up the periodic table. And the mass is 40.08 grams of calcium. There's really no excuse for me not knowing that. I just didn't remember it, to be honest with you. And so we get 1 mole times 40.08 is 40.08 grams of calcium. 2 moles of nitrogen over 1. Okay, we know every 1 mole of nitrogen is 14.01 grams of nitrogen. Okay, which is equal to 28.02 grams of nitrogen. And finally, for every 6 moles of oxygen, we know that every 1 mole of oxygen is going to have a mass of 16.00 grams of oxygen. That is a decimal right there. Okay, which we already said is equal to 96.00 grams of oxygen. Just happens to be the same thing. Now to find out the total molar mass, we have to add them all up. Okay, so we'll come over here. We're going to hit, we'll clear that out. And we're going to say, okay, we've got 40.08 for the mass of calcium plus 28.02 for the mass of the hydrogen plus 96.00 for the mass of the oxygen. Add it all up, and we find out that we have a total molar mass of, just trying to verify here, yep, of 164. Come back over here. Whoops, that's not what I wanted to try to do. Try to get that straightened out again. Ah, boy, now I did it. Alright, I don't know what I did here. Oh, that's why. I had to go over here. Okay, there we go. Now we can figure out that it's equal to 164.10 grams of CaNO3 per 1 mole. So I know this is a lot. I hope you found it helpful. We will be doing a little bit more practice in class, but this is the general gist of what's going on here. Okay? Thanks a lot, guys. Appreciate it.